Hi everyone, thank you for being here, joining me virtually. Today I will be sharing our work on developing the proactive speaker prototype based on Google Home. My name is Jing, I'm from the University of Melbourne. Speaking of motivations, we believe that proactive speakers can be quite useful in the future. For example, we can use it to deliver just-in-time health interventions. However, currently we do not have a commercially available proactive speaker. In order to get one, we can either fake it, for example, we can use a laptop or smartphone to act as a speaker, or we can build one from scratch. Both methods have their own drawbacks and flaws, therefore we propose a workaround, which is instead of having a real human to activate the speaker all the time, we can build a secret agent to activate the smart speaker. The speaker can be activated in a way that the nearby users have no idea of what's going on. To achieve this, with our workaround, we build a proactive speaker prototype with a Raspberry Pi and a Google Home. The Google Home has two visible microphone ports on its top surface. We attach a pair of earphones to those ports, and we power those earphones with the Raspberry Pi that we have. We store pre-recorded voice commands to the Raspberry Pi, and we can schedule the proactive prompting by having the Raspberry Pi to play the pre-recorded voice commands. Additionally, we have installed a light sensor to the Raspberry Pi to detect the ambient light, and a USB microphone to detect the ambient noise, as well as record the real-time interaction between users and the speaker. We also measure user proximity by utilizing the Bluetooth signal scanner inside the Raspberry Pi. We attach the pair of earphones with a 3D printed headband. You may wonder how robust is our prototype and what can we do with it? We conduct an in-the-wild study and deploy the prototype in different people's home. We build a voice-based experience sampling method application and publish it as a Google action. This application can collect personal context by asking questions. Specifically, the speaker will ask 4 questions. The first one is rate your availability on a scale of 1 to 5. If the user gives a numerical answer, then the speaker will continue to ask the second question about boredom, then about mood, then about the current activity. Additionally, we also designed 3 conversation starters to test in which way the speaker should initiate a conversation. The first starter is a baseline condition, which is no starter, and the second starter is the ear con. The speaker will play a 4-second music clip first before asking the first question. The last one is the utterance starter. The speaker will ask, "Hey, are you available?" If the user answers yes, then the speaker will ask the voice ESM. We use the last one to imitate a natural communication between 2 humans. The preliminary results suggest that our prototype is robust in the wild. The activation rate of the prototype is around 90% for all 3 conditions. With 7 participants, the prototype prompted around 2,000 ESM surveys and received 771 responses from participants. The response rate is 39%. We hope our prototype can be used as a tool for research around proactive voice user interface, and it can be used as a new platform for data collection via voice. This concludes my presentation. Thank you for joining me virtually. If you want to check out our demo, how the proactive speaker prototype works, please scan the QR code there. Thank you.